You know that feeling when you just have to hit repeat on a song? Ever wonder why? Well, it turns out there's a whole lot of science hiding inside your favorite music, and that's what we're digging into today.
Seriously, just think about it. How does the music coming out of your headphones actually get into your brain? How does it go from being, just a file on your phone to something that makes you feel happy or sad or just want to dance? How does that even happen?
And look, it might feel like magic, but I promise you, it's not. It is pure, amazing science. So let's break it down, step by step, right from the start.
All right, so part one is called making waves. And this is literally about how sound gets from there to here, from the speaker to your ears.
Okay, so first things first, sound isn't just some invisible thing. It's actually a form of energy. Whenever something makes a noise, it's vibrating, and that vibration sets off a kind of chain reaction in all the little air particles around it. The best way to picture it, think about dropping a rock into a still pond. See those ripples spreading out? That's basically what sound waves are doing in the air all around you all the time.
And these invisible ripples, they are moving so fast. In dry air, the speed of sound is about 767 miles per hour. To put that in perspective, that's faster than most jetliners fly. It's just wild.
But here's a really cool little fact that proves sound needs stuff to travel through, like air. In space, which is a vacuum, there's nothing for the vibrations to travel on, so it is completely, totally silent. Yeah, that means all those huge explosions you see in sci-fi movies, in reality, you wouldn't hear a single thing. Weird, right?
Okay, so we've got these waves of energy flying through the air. But how do we organize those random vibrations into actual music? Well, that's what brings us to part two, from noise to notes. We're going to look at the science behind musical instruments.
So, the most important idea here is something called frequency. It's really just a fancy word for how fast something is vibrating. And that speed, that's what our brain understands as pitch. How high or low a note sounds. We measure it in a unit called hertz or hertz.
And the relationship is super simple. A high frequency means tons of fast vibrations, which gives you a high-pitched sound, like a flute. And a low frequency? That's from slower vibrations, giving you a deep, low-pitched sound, like a tuba. It's really that easy. Fast vibrations, high note. Slow vibrations, low note.
Okay, but if you've ever plucked a single string that's not attached to anything, you know it's pretty quiet. So how do instruments get loud enough for us to hear? The secret sauce is a word called resonance. The best way to think of it is like teamwork. When you pluck a guitar string, it makes the whole wooden body of the guitar start vibrating with it. And that team up makes the sound way, way louder and gives it that awesome, rich quality we love.
And the materials used to make instruments, that's not random at all. It's pure science. Well, chemistry, really. A trumpet is made of brass, which is a mix of copper and zinc because it's super durable and resonates perfectly. A clarinet uses a special dense wood so it doesn't bend or warp. And the strings inside a piano, they're made of high-carbon steel so they can handle a ton of tension. Every single material is chosen for a specific scientific reason, all to get that perfect sound.
All right, so the instrument made the perfect sound wave and it's flying through the air towards you. What happens when it gets there? Well, that's part three, how we hear music. We're about to follow that wave on its incredible journey right into your ear.
And right away, here's an amazing fact. Deep inside your middle ear, there are 3 tiny bones. And when I say tiny, I mean it. They are the smallest bones in the entire human body, and they have a huge job to do.
The whole thing works like this incredible tiny machine. First, the shape of your outer ear acts like a funnel, catching the sound waves and sending them inside. That makes your eardrum vibrate. Then, those 3 tiny bones we just talked about, they take that vibration and make it stronger. From there, it goes into a snail-shaped thing called the cochlea, which is filled with liquid. The vibration becomes a wave in that liquid. And finally, tiny little hair cells turn those liquid waves into electrical signals, which get sent straight to your brain. In just a split second, a wave in the air has become a signal inside your head. It's incredible.
Okay, so the signal reached the brain. Mission accomplished, right? But wait, that's just an electrical pulse. How does that explain why a sad song actually makes you feel sad? How does a simple signal turn into a powerful emotion?
Well, that question takes us to our next section, Part 4, Your Brain on Beats. We're going deep inside the mind to figure out the amazing reason music can give you all the feels.
A huge part of the answer comes down to one chemical, dopamine. You know that amazing feeling when the beat drops in your favorite song, or when that perfect chorus hits? That's your brain releasing this feel-good chemical. It's the same stuff your brain releases for other things you really enjoy.
And that's just the start. Music has all these other superpowers for your brain. A fast tempo can literally give you more energy for a workout. A slow, calm melody can help you relax. The right kind of music can even help you focus when you're studying. And what about that thing where a song comes on and bam, you're instantly thinking of an old memory? That's your brain's powerful connection between sound and memory. It's so strong that music is actually used in therapy to help reduce stress. So we've gone from how sound is made to how we hear it. Now let's talk about how we started to control it. This is part 5, capturing and creating sound. It's all about the amazing tech that lets us record our favorite songs and even invent totally new sounds from scratch.
The history of recording sound is a pretty wild story. I mean, it started with things like wax cylinders, where sound vibrations were physically etched into grooves on a cylinder. Then we got microphones, which was a game changer. They could turn those physical sound waves into electrical signals. And now, we take those electrical signals and turn them into computer code. Just a bunch of ones and zeros that becomes an MP3 file on your phone.
And this is where science doesn't just explain art, it creates new art. Think about electronic music. It's literally born from the science of electricity. Instruments like synthesizers use special circuits to generate brand new sound waves from nothing. They're basically creating sound from scratch, allowing artists to make sounds that just don't exist anywhere in nature.
So, where is all this heading? The future is looking pretty incredible. We're already seeing AI that can compose its own hit songs. Imagine attending a concert in virtual reality, right from your own home. Scientists are even looking into using specific sound frequencies for healing. Seriously, the line between science, tech, and music is getting blurrier and blurrier. And when you step back and look at it, it really brings everything together. Music is this perfect partnership. You've got the physics of the sound wave, the chemistry of the instrument, and the biology of how we hear it. It just proves that art and logic aren't fighting each other. They're working together to make the human experience that much richer.
So I'll leave you with this one last thing to think about. We've seen how science can explain, capture, and even create music. But if an AI can learn how to write the perfect, chart-topping hit song, what does that mean for us? For human creativity? What is that little spark that makes a song truly special? Something to chew on the next time you hit play.